In question 1, we're going to answer some questions about this polynomial, mostly by using this graph. Starting with, what are the zeros of this function? A zero is any x value that makes the y value equal 0. And there's a total of 3. It's any time that your graph is on the x-axis. So there's 1, 2, and 3. Those numbers are x is equal to -4. That's a 0. So is x is equal to -2. And x is equal to +1. Now notice with these 3 zeros, sometimes the function crosses the axis and sometimes it stays on the same side. It is the multiplicity of those zeros that determines this. So which of the zeros have an even multiplicity? An even multiplicity means stay on the same side. So that's going to be this one. So therefore, x is equal to -2 has an even multiplicity. Which of these 3 zeros therefore has an odd multiplicity? It has to be this one and this one. An odd multiplicity means that your function crosses over the axis. So that is going to be -4 and also +1. Now from this information, we can figure out what the actual equation for this graph is. And we got to circle the correct one here. Just to label the zeros again, because they were on the previous slide, that was x is equal to -4, x is equal to -2, and x is equal to +1. Those are the zeros. The factors that would have to appear in the equation are x plus 4, x plus 2, and x minus 1. The reason these are zeros is because if you put them into the factor, it makes the factor equal 0. So like if you put -4 here, the factor becomes 0. -2 makes this factor 0, and 1 will give us 0 in this factor. These must appear in the correct equation. So, we can eliminate this one. I know the answer is, it's not this. Notice that that has an x minus 4, an x minus 2, an x plus 1. That's no good. So it's down to this one or this one. Notice that the factors are all correct, but the exponents are different. So this is where multiplicity will come into play. For this 0 and this 0, it's an odd multiplicity. That means on this factor and this factor, I'm looking for an odd exponent. That happens here and here. They're not written, but the exponent on both of those are 1, and that's an odd number. X was equal to -2 has an even multiplicity, and that's determined by the even exponent, this 2. So, this top one is not correct. The multiplicities don't match up. But the correct equation is this one here. For question 2, I'd like to solve this inequality, a quadratic inequality, by following these 4 steps. The way to do this is first ignore the less than and just solve the equals. Label those points on a number line, and then around those points determine where the function is positive and negative. So let's start here. Where's x squared plus x minus 6 actually equal to 0? You could use the quadratic formula, but we can factor this thing, I think, pretty easily. I believe we can break it up into 2 pieces. We'll have an x and an x. You have to have a positive and a negative because the last number is negative. So I think it's going to be +3 and -2. 3 and -2 multiply to -6, but they add to a +1, which is in front of the x. We can now set each factor equal to 0 and solve it for x. So I would subtract 3, and this one I'll add 2, and we get our 2 solutions. X is equal to -3, as well as x is equal to +2. So that was part A, finding our solutions. I will now plot those on the number line in part B. Let's see. Okay, so -3, that's a 0, so it's +2. For part C, I'm now going to choose numbers in each of these 3 locations to figure out if the function here is positive or negative. So like -4, what happens if you put -4 into this function? Let's see, f of -4, that means you square -4, you then add -4, and then subtract 6. And the number I get back is 6. And all I really care about is that it's greater than 0, it's positive. So if it's positive here, that means it's positive in this location. So I'm just going to note it's positive over here. Now, what if I choose a number in between here, like 0? If I look at f of 0, again, plugging that into the function, that is 0 squared plus 0 minus 6. And if I do the math on that, I get -6. All right, this is negative. It's less than 0. So here it's negative. It's got to be that it goes back to positive again, but just to be careful, I'll take 3, put that into this function, and see what we get back. All right, so f of 3 is equal to, so that's 3 squared, plus 3 minus 6. Definitely going to be positive. Actually, it's positive 6. F of 3 is 6. That's a positive number, so it's positive over here. We can now use this number line that I've labeled to solve the inequality. I want to include all of the x values that are either equal to 0 or less than 0. Well, none of this stuff is less than 0. It's positive. Same thing here. This is all positive. I don't want to include that. The stuff that is less than 0 or equal to 0 is everything from here to here. So just by using this number line, I can see that this is the answer. You could express it, well, I say write it as an interval. You could write it as all of the x's from -3 to +2. But as an interval, you would write it like this. So here I'm using brackets because we are actually including the zeros because there's an equals part to this inequality. If it was strictly less than, I would use parentheses. That did not happen, but this is the answer to the question.